All right, welcome to class. The first thing that I need you to do is take out your lab books. And if you would, please take out your periodic tables. Now, as we go throughout this, we'll have the substitute pause once in a while and have you work through some questions. So I believe I don't even have the right version, so just stick with me. This is like page 8, 9, or 10. I really don't have any idea, so we'll say around 10. And we're going to talk about this concept of the mole. Now, the reason you need your periodic table, go ahead and take that out and find the side with the numbers on it. And we'll just talk about iron as we go throughout this. Okay, so to begin, first thing you need is your lab books out here, and then your periodic tables open. What we're going to talk about today is not something that's very difficult, but it's something that's extremely important for you to understand for this class and for Part B. So please make sure that you're paying 100% attention the entire time. All right, so let me see, 1 second here. All right, I think that should be a little bit bigger now. Nope, looks about the same. All right, so here we go. The warm and fuzzy mole, and we're not talking about this little creature right here, or that warm and fuzzy mole that everyone has on their back or wherever. I know that's gross, but whatever. All right, the mole actually for us in chemistry is going to be pretty much the following. The mole is a word that means a really, really big number. All right, in fact, that number is this number, which is giant. And no one likes writing this number because it's just a tremendous pain to write. So no chemist in the world would write this number down. So just like the word dozen means the number 12, or it means a number, the word mole is going to mean a number. It's going to mean that giant number. But you don't really need to know that much. If you will just essentially lock in this, that a mole is equal to like half a dozen, you'll get close enough because half a dozen is around 6 and the mole is 6.02 times 10 to the 23rd. And I say close enough, I mean you're 23 zeros off. But you don't have to know that number. You just need to know that a mole really is a number that means, or it's a word, I mean, like dozen, that means a number. So let's go back here real quick. So chemists have devised a means of keeping track of the amount of matter involved in chemical reactions. This method uses the gram formula mass, better known as the molar mass, or mole, for short. Okay, there's that word. Remember, write this on like the front of your lab book or something. It's something that you should absolutely remember. Mole means big number. It's just a word that means a number. And what it really means when we talk about it in chemistry is 1 mole equals this many atoms. And we'll talk about that as we go through here. All right, now, next point here. In each element box in the periodic table, there are 2 numbers. The molar mass of an element is the larger of these 2 numbers. All right, and we'll look here in a second, but the molar mass of carbon is 12 grams per mole rounded off. So let's go here and let's talk carbon. Okay, so it's probably too small to see on the screen, but look on your own periodic table. you will notice quite easily that there are two numbers in the box for carbon. There's a 12 and there's a 6. Well, one of them's bigger than the other. The 12 is a larger value number than 6. So we would say that carbon has a mass of 12 grams. And now what we're really going to say is carbon has a mass of 12 grams per every 1 mole. Which means, remember, mole means a word that is a huge number. It means if I had that big number of carbon atoms, they would weigh 12 grams or have a mass of 12 grams. Okay? So really, finding the molar mass of something is extremely easy. You just look at the thing, find the bigger of the two values, and that would be your answer. So scandium, 45 grams per 1 mole. I kind of have a habit of doing this because on my slate, lifting up my hand takes just a little bit more time. So that's a G and a slash all in one. And let's just review, since you've probably already forgotten. This word mole, that means a big number. Remember, like 602 and then 21 zeros behind it. It means a really big number. And if I had that really big number of scandium atoms, I would have 45 grams. Let's get rid of all this garbage. All right? So, when you look at the numbers on the periodic table now, know that they're always listed as grams per 1 mole or grams for a whole heck of a lot of things. That number is written right there on Marvin the Mole's shirt also. All right, so let's look right here. This will be a simple activity. You can pause it here in a second, but it says, what is the molar mass of each of the following elements? Be sure to include the units. So cobalt, we would just come over here. We would find cobalt. Cobalt has a 59 and a 27. Well, 59 is a bigger number, so we would say cobalt has a molar mass of 59 grams per 1 mole. That would be the correct way to write that. If you don't like my G slash, then write your own G and your own slash separately. And let's just review, since I know you're tired of it. But if I had 1 mole of cobalt, or if I had 602, and well, I'm not going to keep doing it, but that many zeros, atoms of cobalt, they would have a mass of 59 grams. All right, so go ahead in your lab book and do these 6. Go ahead and pause this, please, and fill out those 6. Okay, let's go ahead and jump to the next thing. The first thing I would like you to do is take 30 seconds and explain to your partner what a mole is. 30 seconds. Ready, set, go. Okay, hopefully most of you said it's a word, which means a big number. And it's how we keep track of stuff when we do math using chemistry. And that has a name. It's a weird name, stoichiometry. And what we're doing right now is just the very basics of what we call stoichiometry. It gets a lot more complicated in part B, but not too bad. Stoichiometry is a nerdy word. I actually learned this tonight. Stoichiometry is Greek for counting elements. There you go. So it's literally keeping track of what's happening with the amount of elements as we do this. All right, let's get back to this. All right, did that. Let's come here. All right. So, hey, I didn't get to this slide yet. You're going to be sick of this. But 1 mole of anything means that many anythings. So really, we don't really have to have an element of mole. We could have a mole of dollars. That's an ugly dollar bill sign. That would mean I would have that many dollars, which means I would be the richest person ever born. I could have that many shoes. If I have that many shoes, or if I have a mole of shoes, that means I have this many shoes, and my name would be Jesse Roberts. All right, so let's move on. I keep saying that, but let's really move on this time. All right, lower on the page. All right, so it was simple when we said carbon had a 12 and a 6. Now, do me one favor. Do not memorize that the top is the molar mass and the bottom is the atomic number, because some periodic tables will put 6, C, 12. It's the larger of the number is the molar mass. All right, so it was easy to find that. Carbon was 12, but now we're going to find it for molecules, which isn't super hard. It just takes a little bit more time. To find out what the mass of a molecule, so that's things that are slammed together, you must first count up the different, I don't know, I'm going to say types and number of atoms. For example, CuSO4. I'm going to do one different. For example, CO2. This is very simple. CO2 is a molecule made out of 1 carbon and 2 oxygens. The subscript tells me how many there are. Okay. Hold on. There we go. All right, so this subscript, it gives me the idea of how many things I'm talking about. Now, it gets a little bit complicated, so let's go to up here. All right, so we got that. So first count up the number of types of atoms in the following. So CuSO4, all you're doing here, there's 1 copper atom. If there's not a number, it's a 1. There's 1 sulfur atom, because this 4 only belongs to the O, so there's 4 there. So this is very simple. Don't overthink this. This is just asking you to type or count up the number and types of atoms. So what we have 2 hydrogens. Piece of cake. Here we have 1 aluminum and 3 chlorine. You can do that one on your own, but look here. Make sure that you are okay with this. I'm going to make this on a larger page. So it's CaNO3, 2. Make sure you know how this subscript right here works. This 2 means there's 2 of everything. So it would be like an Na, oh man, I did this in AP chemistry yesterday too. It'd be like NO3, CaNO3. That would be the real compound represented by this formula. So notice that there's actually 2 times 3, or 6 oxygen, 2 times 1, or 2 nitrogen. And this 2 only belongs to what's in the parentheses, so there's 1 Ca. And we can see that. We have 6 oxygens, 2 nitrogens, and 1 Ca. Okay, go back. We did that one, and we're golden. Okay, so the first step is just to determine what your parts are. You okay with that? I'm talking to a computer screen, so ask your partner if they're okay with that. All right, the next thing we would do here is multiply the number of each atom by the molar mass of that element. So here we go. Here's our example. We know that we had 1 Cu, we had 1 S, and we had 4 oxygen. I know O is just O, but I put the X because I don't want you to think it's a 0. All right, so now we use our periodic tables. I wish I could just see this a little bit bigger. So we'll use our periodic tables to find the mass of each one. So I go to periodic table and I find copper, and it's right here, and the larger number is 63.5. So now I come back, it's down here at the bottom. So now I put 63.5. That's what copper's molar mass is, grams/mole. Sulfur, I'm not going to go back because that was a pain, but it's 32 grams per mole. And oxygen is 16 grams per mole. All right, so go ahead and take your calculators out, and you would do the following. And I know you won't, but whatever. 1 times 63.5 plus 1 times 32 plus 4 times 16. So 64, 96, 149.5, no, 159.5 grams per 1 mole. And I could be off a touch there, I just did it in my head. And it's getting late. I'm old, and it's past my bedtime. But the process, very simple. Find out how many there are of each thing and multiply it by its molar mass. How many there are of each thing, multiply it by its molar mass. How many there are of each thing, multiply it by its molar mass, and then add them all together to get the mass of the molecule, or the total mass of the thing. All right, let's come down. It asks you now to do that again. Number 1 is easy, so I will do number 2 with you. So I had 1 aluminum. Okay, I'm just going to put aluminum under. Plus, this is dumb, can't do that math in my head. 3, there are 3 here, times the mass of chlorine. So I'm going to look on my periodic table. I will tell you right now, aluminum is 27. That's the larger of the 2 numbers. And remember, that's 27 grams per 1 mole, meaning 27 grams for every huge number of them. I know you're tired of that. All right, so now that's 27. And chlorine, if you look on your periodic table, is 35.5. All right, so I take 3 times 35, that's 105, 106.5, plus 27 more, that is 133.5 grams per 1 mole. All right, so 133.5 grams. Okay, go ahead and time or pause it. Take the time that you need to find the molar mass of that, and of that. If you don't know what you're doing, ask your lab partner for help. I'm sure that one of the 2 of you know. If neither one of you know, then you should start paying attention better. All right, let's just double check. 133.5 grams. This was 180 grams, and these were per 1 mole. 1 mole. And calcium nitrate. I don't want to do the math there, so let's just figure out what this is. So we'll type that in. 164 will be our answer. If you have phones with Siri, you can actually ask, and Siri will know. Now, you have to know what this is called, so you would have to know that's calcium nitrate. And by part B, you'll know how to do that. Okay, so just double check those, make sure that you're solid. This was just 2 grams per mole. Okay, Hopefully you're okay with that. Now there is, if you would, turn to your homework now. All right, so the version I have on my laptop of the lab book might be a little bit old. Wah, wah, wah. I don't know. But turn to your homework, and it asks you to find the formula masses. And it's the same numbers. We start on 35. I just don't remember if this is how we did it. Take no more than 3 or 4 minutes and pause it and see if you can figure these out. Um, some of these are big, like this is going to be a big number, but that's okay because mercury is uh, a heavy atom. So take some time. If they don't match and there's only 4 of them, which my gut feeling says there's only 4 of them, do the 4 of them. So remember, I'll do NO3 with you just as a reminder. NO3, there is 1N, and its mass is 14. I'm going to add that to 3 oxygens, and its mass is 16. All right, so 48 plus 14, that is 62 grams per 1 mole. Now, I probably did this right, but I do screw up a lot when I do math in my head while I'm trying to record. It's hard, okay? Get over it. Okay, pause this and take a few minutes and fix or finish those. Okay, now turn back to your notes page, to whatever page this is on. Um, Everything we've been doing has been trying to set us up for what we're about to do. And what we're about to do in the long run is supposed to be very easy. If it's not, it's okay, but it will be something pretty easy. So just relax. We'll figure it out together. We're going to frame together what we did yesterday in class to what we did today in class, and take our picket fences and make them talk about chemistry. So you now know how to construct a proportion. Okay, a proportion. Remember, that's a relationship between 2 things that change the multiple of the other. All right, for the molar mass of a substance. If you remember, every time we did this, we said like carbon was 12 grams per 1 mole. That's your proportion, which could certainly be written, by the way, as, that's not the blank, so don't follow that arrow. Let's go right here. It could be written as carbon for every 1 mole has a mass of 12 grams. Okay? Remember, proportions can flip either way. So here we go. We have our proportion, whatever. Our molar mass is equal to grams over mole. We can use this proportion with the picket fence. Oh, here we go. To calculate the number of moles or the number of grams in a quantity of a substance. Okay, so we have moles and we have grams. And they are related to each other. I'm going to put this equal sign. But this equal sign really only exists because of molar mass. It's the thing that will relate the moles to the grams. All right? So we can do this process, and it's super not that hard. All right? So how many moles are in 26, kind of gave away the answer. No, I didn't. It's 13. Anyway, how many moles are in 26 grams of H2? Okay, follow me here. Anytime I give you this, we're going to call this the hidden, I don't know how to spell that. If there's only one D, don't laugh at me. Proportions. Okay? The formula I give you is always the hidden proportion. It means that there's only one number here, but really there's 2 because it's hidden in that proportion because H2 there are 2 hydrogens. The molar mass of each one is 1. So 2 times 1 equals 2 grams per 1 mole. This is my hidden proportion. Okay? If I give you a formula, you always have to find it, and we'll call it the hidden proportion because it's not outwardly written as a number. You have to find it. Okay, so remember the steps from yesterday, and it's right here, but it's just kind of, it's out of place. So let's just do it right here. We have our proportions. It was 2 grams per 1 mole, and we have our 26 grams. So our picket fence, we first decide what we need to solve for in the answer. How many moles? So you have your plus sign and you write moles. Then, remember, we said our loner is what we always start with in the top left. And then we love the picket fence. Well, I love it. You can hate it. I don't care. Our picket fence is awesome because the unit that's right here always is the unit that goes down here. For every gram, we're going to have 2 of them. And the proportion that it's tied to is 1 mole. So I have 26 grams. Grams cancel out. I have leftover of moles, which is what I want. So it's just 26 divided by 2 is 13. And you know what? I just spent 3 or 4 minutes explaining something that would take you 10 seconds. I know. But I also know that everything I'm doing for you right now, it's for your own good. Now, you didn't trust your parents when you said that. I don't expect you to trust me, but please try to do it my way. All right, so here we go. This problem, I keep scanning the wrong way. This one was finding moles. Uh-oh, don't do this to me. That's not what I want. This one was finding moles given a gram. The next one will be the reverse, finding grams given moles. So how many grams? Let's just set this thing up. And yeah, I'm not an idiot. I know it's right here, but I'm walking you through it. Stick with me. Are in 2.1 moles of this stuff. Ding, 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 ding. Tell your lab partner right now, what do we call this? Okay, good. It is our hidden proportion. I'm sick of writing that word. All right, so we already had found this earlier. An Al plus 3 chlorines was 135 grams per mole. So that's 1 Al plus 3 times 35.5. That's how we got that number. Okay, so now I look up here. This is my loner, 2.1 moles. All right, here's my hidden proportion was 133.5 grams per mole. Now, if you didn't use a picket fence, you might be confused on which one goes down. Remember, the moles, if it's up here, now it has to go down there. So for every 1 mole, we have 133.5 grams. So now, and that's what number goes right there in that blank. Now we would do the math and get 280.4 grams. All right? We know this works because our units cancel out to leave the one that's 1. Now you might think, well, that doesn't make sense. It doesn't match what I just did on the previous one. Well, that's right, because the previous one, we were going a different direction. We were solving for moles given grams. This one, we were solving for grams given moles. Let's do an example. Probably won't be able to do the math in my head, but we'll find out. Okay, so here we go. How many moles? So first off, it's going to be hard to write straight, but we'll try. Hey, that's not bad. I'm going to put that I'm looking for moles. And then the thing that I gave you right there, I'm going to start with it right there, 107 grams. All right, now, we already had calculated this. You can spend your time doing it again. But it is 180 grams per 1 mole. So I look over here. This unit tells me the bottom over here is 180. And I have that for every 1 mole. So it's 107 divided by 180. I do not know that answer, but I'm going to guess it's around 0.62. I could be way off. You can type it in. All right. Now, listen. This is a side note. When solving for moles, the answer is usually small. When solving for grams, the answer is usually big. Now, that's not like perfect, but it's pretty close to being perfect. All right, this was for moles, 4 is for grams. Let's help you out on that one. So I have 8.3 moles, that will be my loner. I'm solving for grams. And this is my hidden proportion, which we did at some point in time. I don't remember what it was. We looked it up on the internet, didn't we? It was 164. And I round, okay? Please just round. You don't need to be perfect in this class. So it's 164 grams per 1 mole. So I come over here. I know that I have moles on top, so that unit has to go down. So for every 1 mole, I have 164 grams. Multiply that by 8. Oh, 848. I'm going to say this is like 1310. And that's probably super far off. It was just an absolute guess. Okay. It's raining like crazy outside right now. Go ahead. Pause this. Well, don't pause it yet. Do number 5. Do number 6. If you have time after that, then we'll go and do the homework back in your lab books, problem 41 through 44. Okay, if you have time, you should be here. I will help you on 41. It says you're given 27 grams of each of the following substances. That makes this super nice because every one of these picket fences will be set up pretty much the same. All right, because you're always going to start with the given or the thing that's alone, and it tells you, and I'm sorry OCD people, those are all terrible, but whatever. It tells you have 27 grams of all of them. All right, so then all you would have to do is find the hidden proportions of each one of these. Let me do 43, 40 here in a second. And then just set them up. Grams on the bottom, moles on the top. They're all the same. Okay, let's talk about this real fast and then we'll be done for the day. Na2CO3.10H2O. All right, this is a hydrate, which means it has water. In fact, it has 10 of them. So I'm just going to tell you right now, water adds up to 18. So 10 of these is 180. Then I'm going to take all of these parts and add them up. And I can't remember, but I think this is the one that might add to 100. Well, 48, 60, it doesn't. Like, oh crap, I think it's like 98. I'm getting worse on my head. 46, that's not right. Anyway, it's a number, maybe 106. I'm trying to remember every single one of their masses and do all the math at the same time, whatever. So let's just say I'm right, it's 286, but I'm probably wrong. But just know, it just means attached to. All right, so go ahead, let's wrap this up. Do as many of these homework problems as you can, and hopefully this has helped because I do expect to come back and you guys to have a decent understanding of this. Okay, thank you.